All right, the broadcast is started.
Perfect. Okay. So do you guys just want to jump right into it?
That sounds good to me.
All right.
Yeah. I'm just warning y'all in advance. I understand everything, but I don't understand until I read the answer or something like that. It all makes sense to me, but figuring out for myself takes forever. So, just a fair warning.
Okay.
Okay.
Go. Okay, who wants to read? I can read. Is everyone ready?
Yeah, I'm ready.
Okay. So,
Yeah, right.
3. Use the normal probability applet to find... Am I on the right one? I'm on the right one, right?
Are you on lesson 6?
No, I'm on 7. Ah! Okay, I can save for later.
Are we on 6?
Yeah, I just picked that one.
We're just going to do both lessons tonight, right? Just so that we can...
Yeah.
Okay, cool.
Yeah.
Okay. So when using and when taking samples of n equals 5, what it was the shape of the distribution of means histogram when the parent population is right skewed?
Right?
Yeah.
Yep.
I think so.
I got cord. Go over there. Sorry.
Oh, you're fine. I'm just in a group meeting.
I'm sorry.
Oh, you're fine. Okay, so skewed right. Is that what we're going with?
Yes.
When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed?
Normal?
Yeah.
Is it because it's bigger? Is
Yeah.
that
Yeah.
If it's
Okay.
larger than
The
30.
sample.
okay?
Yeah.
Gotcha. It's just the rules. I'm not good with that. Okay. When using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed?
Normal? Right?
Yep.
Yeah.
Okay.
When taking samples of when n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Normal.
Okay.
Right.
Why is the other one normal? Why is 5 normal?
Because the parent population is normal.
Okay.
Yeah.
So if the parent population is normal and the sample size is small, then it's likely the sample is going to be normal. But if it's skewed either way and the sample size is small, then it's going to be skewed. But if it's over 30, then it's generally normal.
Yep,
Okay.
that's correct.
Sounds good. When would the distribution of means be normally distributed? So,
Nice trash.
yes. Data are drawn from a population that is normally distributed and the sample size is small. So,
Population is normally distributed and the sample size is small. So that one's a yes.
Yep.
okay. And data are drawn from a population that is normally distributed and the sample size is large.
That's a yes.
So when it's normally distributed and the sample size is small or large, it's going to be normal?
Mm-hmm.
Okay, got it. Data are drawn from a population that is right skewed and the sample size is small. So that's skewed, right? Okay. Data are drawn from the population that is right skewed and the sample size is large, and that's also skewed. Correct.
No.
What is
If
that?
the sample size is large, then it'll be normally distributed.
Probably?
Assuming it's normally distributed.
Okay.
It's not like a guarantee, but it's just assumed.
Okay, so it is normally.
Yes, so that one's checked too. So 3 of them should be checked.
Yep.
Okay. Which of the following gives the best explanation of the central limit theorem? If the parent population from which of the data are drawn is normally distributed when the sample mean will follow a normal distribution. How about we just read them? I feel like it'll take longer for me to read all those.
This is probably discussed. I can't remember.
Central limit theorem. Just this one.
I think it's the last one. It says sample size is large. The shape of the sampling distribution of the sample mean will be approximately normal. That's the central limit theorem. Because the third one is the only other one that I would have thought of, and that one I'm pretty sure is the large numbers one.
So I just get them mixed up constantly. I don't know which one.
Yeah, it is kind of confusing, but I think that's right.
Because the large. I'm gonna check it. Y'all can go on to the next one. I'm just nervous.
Okay.
Okay.
Just a second. Let x be a random variable with population mean 10 and a population standard deviation 6. Suppose a sample of size 36 is drawn from this population. What is the mean of the distribution sample means? So I didn't understand that. That's like question 2. That's the example where it's like question 2 for answering following questions. So is it just 10? Is that what it is?
Mm-hmm.
Okay.
Population.
I was just confused because I thought it would be harder for some reason. Okay. What is the standard deviation of the distribution of sample means? So standard deviation would be 6, right?
So we have to do. Is that the one where we have to do the square root?
I believe so. Yeah.
Okay. So. So this, you'd put in 6 divided by 36 in the square root of that, right?
Oh, okay. Yeah. Okay, I see. Okay, 36.
It's 1. Is that right? I don't think that's right.
Yeah, that's what I got.
Right. Okay, then we'll go with that. Yeah, because it's 6 and 36, that would make sense.
Yeah.
Okay.
Regardless of the distribution of the population, if the sample size is large, what would be the shape distribution of the sample mean?
If the sample size is large, what would be the shape? Oh, normal?
Yep.
And what theorem would justify your response to question 11?
Law of large numbers. Is that right?
Let me think for a second.
Law of large numbers. Sample size increases the standard deviation. Oh, maybe not.
I think it's because remember we
If
answered
the sample size
question.
is large, then the sample mean will approximately be normally distributed. So, central limit.
Exactly.
Trick question.
Okay.
So it's central limit. Okay. Is that all?
Yeah, that's all of them.
Sweet.
Okay. I'm gonna submit.
100. Beautiful, y'all.
Good job, team.
Alright.
Michael, did you take these already?
I did. I took them yesterday.
Awesome.
You're ahead of the game all the time.
Yeah. Feel bad. I just like have more comfort taking it with y'all. I don't know.
Yeah,
So.
me too. Because I understand it. Like I thought I really understood last week's, and then I took the homework, and I didn't do as good. And so I don't know. Maybe
That's
it's
just funny. Last week when y'all explained everything to me, I thought I understood it, and then I had to retake one of my homework quizzes because I didn't do good on it at all. So.
I'm really bad at math, apparently. But that's not really that much of a surprise. I already knew that. So, okay.
Second one.
Yeah. So you guys want to do number lesson 7?
Okay, this one I'm like really not good in, so we'll see how we do. Just warning you in advance.
All right. I'm gonna pull up the reading really quick so I can look at it too.
Okay, Michael, we're gonna be using you a lot.
Okay.
All right. We're
I'll read this time if you want me to. Do you have the quiz open?
Huh?
Do you have the quiz open?
Yeah, I do.
Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to 3 decimal places. Blah, blah, blah. Okay, so normal probability applet to find the combined area under the standard normal curve that is to the right and to the left. Okay,
Pull that out.
do this. I have to go find... Pull up the applet.
I think the applet link is in lesson 5, if I remember right.
Yeah, it is. I feel like there's a way you can get to it without having to go.
I just type it in on Google. I type in normal probability applet. It's the first thing that pops up.
Oh, really? Okay,
Yeah.
I'm gonna do that because I.
1.3. Okay, so what if we can't get it to 0.358? I'll like adjust the. Oh, can we just type it in? I'm retarded.
Use the phone. Right. Statistics. Yeah.
So the area, Michael, is this right? 0.175?
Yes.
Okay. I'm still doing it.
Do you understand it though?
Yeah, that's what I was going to ask. Do you guys understand?
No, I don't.
Okay, so it says, I'm just explaining this, Michael, to make sure I understand it. So,
That's fine, yeah.
So it says to find the combined area under the standard normal curve that is to the right of the z-score and to the left of the z-score. So on both z-scores, you're going to shade the right and the left, and you're going to type in 1.358 on both of them. And then both those sides are going to be shaded, and the answer is the area to that. Does that make sense?
Okay, so yeah. So one of them, you'll get like the area of. Wait, are you just shading it all in then?
No, you don't shade in the middle. Both sides are shaded, the right and the
Oh,
left.
okay. Yeah. And so then you'd get 0.1745.
Yeah,
Right.
so 1.75.
Perfect. Okay.
0.175, excuse me. Okay, I'll read the next question. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passengers' weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean than was observed in the sample. Oh, okay.
My roommate's laughing at us.
So the mean is 185 pounds.
Okay.
And then the standard deviation is 26.7.
I should have got a piece of paper. That's what I should have done.
And the random sample is 48. Okay. Let's turn B. Wait, so, Michael, do we go by 185 pounds or 177.6?
So you look for the value.
Is he there?
I'm still here.
Oh, okay. Do you know which one do we do the mean of 177.6 or 185?
Let's see. Okay, so the 185, let's see, is the assumed mean weight. It's not actually the mean.
Oh, so that's the y with the little x.
Yeah, I'm pretty sure,
Okay.
if I remember right.
I don't know if that makes sense.
Okay.
So wait, so in the example in the preparation though, because I like rely heavily on the videos, the assumed mean and the actual mean were the same. So how do you do this if they're different?
Okay, let me look at this real quick. Let's see, so are we gonna use the formula with the x minus the mean over the standard deviation over the square root of the
Random
total sample size? Is that correct? Is that what formula we're using, right?
I think
Yeah.
so.
I think
I'm
that's
pretty
the right
sure.
formula. So
Have
I
you
think,
taken
I
this
think
one already?
I took this one already, but I didn't write down my steps. I'm trying to remember how I did it. I think it's 185 is the x. I think that's what that means.
Oh,
185
Put that
x?
in. Well, like not the x, but like the numerator, how it says the number minus the mean. I think the number is 185 and then the mean is 177.6 because they're assuming
Okay.
185. I think that's how I did it.
So 185 is the x, and then 177.6 is the mean? Is
Yeah.
that what
Yeah.
you're saying? Okay.
And the standard deviation is 26.7 over square root of 48. Is that correct?
Yeah. Yeah, try that. See how that comes out, and I'll tell you if it's
Okay,
right. I'm
let
pretty sure
me-
that's how I did it.
Do the calculator. Let's just hope I type all this in right.
Okay.
So we need to do. Oh geez. Okay. So is it 1.921?
Okay. So I think that gives you the z-score, I'm pretty sure. And then
Okay. Oh yeah, that's right. The z-score, and then we have to put that in, and then we have to find the area.
yeah, so that'll tell us the probability. Because the
Find the
z-score,
probability that a random sample captures love weight, how weight that is extreme or more extreme, either above or below. So we need to shade in the right and the left.
yeah, exactly. So try putting that in for the z-score and tell me what you get. No,
Okay.
right.
So we're still on 4, right?
Yes.
Okay. So let me just make sure if I did it right. So the z-score is 17.488.
No.
Okay. I did something wrong then.
Okay, so you should have 185 minus 177.6 over 26.7 divided by square root of 48.
Yeah. I just added it wrong then.
Okay.
What did you get?
I got 1.920. And then the area is 0.0549. Is that right, Michael?
Yes, that's correct. And then you'll just round up to 0.055.
Awesome.
Does that
I feel
make sense?
Yeah.
Does that make sense why we do it like that?
It makes sense.
But
I
it's weird that it
don't
makes
know
sense.
why I added it wrong. Like I get it.
Okay, cool.
So,
It's so weird that I actually understand this.
what did you get for the area?
I got 0.055.
I just added it wrong. I think I put in the wrong square root. I think that's what I did. But yeah.
Yeah, so
Okay.
after she got the answer from the formula, she just put that in as the z-score in the applet.
Yeah.
And then you understand. Because it's extreme below or above, you only shade in the right and left, not the middle. And that's what the answer actually is the area.
Okay. Gotcha. Makes sense.
Woo.
Good job.
Thanks. Which of the are you ready for the next one, Yvonne?
Yeah,
Sorry.
I am ready.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observation, the distribution of the sample means. This cannot be determined. I have no clue.
It's in one of the laws. Like it, I can't remember which one. Let me look. Like it's in one of the definitions of the laws.
Okay.
But that's in this reading, right? It's not in the previous?
Yeah, it's probably in lesson 7 reading.
Okay. I'm looking.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn? Distribution of individual. What's the difference between... Hold on one second. I'm doing homework by like another hour. So bye.
I don't see any laws for lesson 7.
What's the difference between distribution of the individual observation and sample means?
The individual observations. That's actually a really good question. I don't even know what they mean by that. I mean, I know what the answer is because I got it right, but I'm trying to remember how I got it. Let's see.
Was it in the laws in lesson 6?
It probably was.
I feel like that would make sense. I think I'm gonna pull that up again.
Okay.
I remember reading it though. I think it is lesson 6.
Okay.
Okay.
Did you find it?
No, I'm there though. Let me see. Small standard, non. So, would it be part of the central limit theorem, or is it like in like a different law? Which one do you think it would be in?
No clue. Find a smaller standard deviation.
F9. Okay. I feel like I remember reading this.
It's like the main points I got from the two laws was the rules for the mean, not for the standard deviation. So that's what's throwing me off.
Which section of lesson 6 are you at right now?
I'm looking at the form mean and standard deviation of distribution of sample means.
Okay.
So that's
I know I read it. I'm trying to think if there's one.
so. So if it's larger than 1, then the standard deviation of sample means are always smaller than the standard deviation.
Wait, say that again?
I don't know if this is it, but it says if you took samples larger, would 9 observations be samples? Is that?
I would assume so, yeah.
Yeah.
So if you took samples larger than 1, the standard deviation of a sample mean is always smaller than the standard deviation. I feel like this is a riddle, and I'm not going to ever solve it.
Random drawn from a population. Distribution, individual observation. Okay, I feel like it can't be determined. That's just me.
There's
Okay, I'll tell you the answer, and then I'm going to keep looking for it.
Okay.
It's the distribution of the sample means. That one.
Is it because the X has a bar over it?
Oh, I didn't even see that. I think you're right.
independent populations heavily.
I just saw that.
Too.
Because it talked about X bar.
I remember reading this. Like, I really do. I don't, like...
Yeah. Because it talks about the X bar in homework. Is that what that is? Is there's a difference between X and X bar?
I think so. I'm going to keep looking. Let's see.
I think that would be my first idea, but I don't know if that's right. Okay.
Oh, wait a minute. So I think you read this earlier, Yvonne, but in section 4, it's at the bottom of, after the 2 bullet points in section 4, right at the start of it, there's 2 sentences. It starts with, remember these facts are always true.
Yeah.
2 lines, I mean. Skip to the second line, in the last sentence of the second line. It says, also if we took samples larger than n equals 1, the standard deviation of the sample means was always smaller than the standard deviation of the distribution, I guess. I think that's what that symbol means. So I guess the distribution of the sample means, that's why it would be that one. It would be smaller. Because the standard deviations of the sample means is always smaller if the sample size is larger than 1. According to that statement that they put in the book.
The sample mean... Okay, I kind of get that. Kind of. I just feel like it's all jumbled up, so it doesn't necessarily really make sense. I'm just gonna have to study it more.
Okay, well, keep it open for the next question too. So.
Right, yeah, I will.
Because I don't understand the next question either. Which of the following results implies that the spread of X bar decreases as the sample size increases? I have no clue. I'll be straight up. I don't know.
The spread decreases as the sample size increases.
Well, if you look at law of large numbers and you go to the following questions, like you know how they have example questions. Number 4, it says, we just learned that the standard deviation of the sample means is the standard deviation over the square root of n. What happens to the standard deviation of sample means when the sample size is increased? Then you press show solution. The solution says, if the sample size n is increase, then the standard deviation of the sample mean will decrease. So,
Okay. So it's the law of large numbers then.
yeah, because that's pretty much what that question asks, is that statement.
Alright.
Does that make sense?
Yeah. Well,
I'm gonna have to go back and read it again, but yeah. Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the GRE. What is the z-score corresponding to Diane's score? So 160 minus 150.8 over 8.8 is the z-score.
Yeah, exactly.
so wait. So are you using? Okay, I get it. Gotcha.
Does that make sense why we use that formula?
Yeah. Yeah. It's just the normal z-score formula, right?
Yeah, it is.
Okay, so is it 1.045?
Mm-hmm.
Yes.
So, okay.
Oh, 3 decimal places, so 4. No. Oh, okay, that's it. 1.045. Are you good, Yvonne?
Yeah.
Okay,
Yeah, I
what
got
is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So is that, would we use the,
Okay, what is the probability that a random selected student will score above 160? So that's a z-score, and then so this is the z-score for 160, and then we find the area of the stuff shaded left, or right, excuse me, of that?
Yeah.
Is that
so
all?
my question is, would you shade like just the right, or would you shade the middle too? Is it just the right?
Yeah, it's just the right because it's
Okay.
just above 160.
Okay,
That's
gotcha.
the rest.
So then it would be 0.148?
Yeah. And another way to tell, I think we talked about this last week, but like if the if the sample score is less than the actual mean. So for example, if this score was actually like 140 instead of 160, because then it'd be less than 150.8, which is the mean. That's when you would shade the middle end and the right side if you're trying to find something above it.
Okay. So for this example, since it's 160, if they wanted to know what was below, then you would shade the middle and the right, right?
Yeah, middle and the left.
Well, if you wanted to know if it were less. Does that make sense? Because we'd want to find, so if it's just the same, and instead of asking how much more, if we were asking less than 160, it would be the middle and the right, right?
Yeah, like I think it's the middle and the left, like technically, but the middle and the right would work just as well because
Okay,
it's the same on the right and the left sides.
okay.
I'm pretty sure. Like we can test that later, but I'm pretty sure that's how it works.
All right.
Okay, this next question, I think I have an idea of how to do it, but I'm not quite sure.
Okay.
Okay, so a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these student scores? So do you average out all their scores, and then that you put 160 minus or maybe it's not that. It's x. Maybe I'm wrong. I don't know. Do you average out their scores? Is that the first thing you do?
I don't think actually. I think I'm trying to remember.
Do you take them individually and just do it? I don't know.
Because you can only have one answer, so I don't
Yeah.
understand why you do it. What is the z-score corresponding to the sample mean? So it's a sample mean. So does that mean that we have to do the long problem with the square root at the
Yeah.
bottom?
I'm pretty sure that's what you do. I think that's all it's asking. Like those scores aren't applicable right now. But in the next question they'll be useful.
Okay, so you would do the assumed mean, which is the 150.8, and then you would subtract the 160, which is the sample mean. Because you still have to average those out, correct?
That's a good question. I think it's try the 160 minus the 150.8.
160 minus 1?
Because that's the sample mean, right? Or I can't remember.
Because it's the assumed minus the actual. So like the sample.
Okay.
Would it be 150 minus 160 over 8.8 divided by the square root of 5? Because 5 is the sample number.
Oh.
Yeah, I think that's right. Try it and see what you get. I think that's right though.
Okay.
That makes sense.
Let me write this down. 8.8. Whew. I feel like I'm overthinking this. Is it 2.337 or 8?
Yeah, it's 2. Let me see. 2.3. What is it? 2. Okay, 2.338. Yeah, that's correct.
Sweet. I feel so smart.
Does that make
That's
sense? Does that make sense, Avon?
Did you get it, Yvonne?
Yeah.
Sweet. This makes me feel smart.
Yeah, you're doing good.
Okay, are you ready for the next question, Yvonne? Did
Yeah.
you get that one?
Wait, so let me just make sure. It's 2.338. That's what I got.
Yes. Oh, I almost typed it in wrong. Shoot. Okay. But you understood where to plug in each number for the equation?
Mhm.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? 4 decimal places. Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than? Okay, so that's the z-score, so we just have to put that in and then shade the greater than and get the area?
Yeah, try that.
Z-score was what? 2.
So I got 0.0097. Is that right?
Yep.
Okay.
Yep, I got that too.
That's what I got.
Sweet. Okay, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Use the information to answer problems 11 through 15. What is the shape of the sampling distribution of random variable x bar, which represents the sample mean of the 81 students first selected? So would it be left skewed since it's
Yeah,
left?
right? Because if it's left skewed,
Well, okay. What's the sample size?
81. Oh, so it'd be normal.
Yep, that's why. Exactly. Does
Okay.
that make sense,
what
Emma?
is the number for the sample? That's like the limit. Is it like 30?
Yes, 30 is, if it's below 30, then it's small, and if it's above 30 or above, then it's
Large.
large. Yeah, thank you.
So if the sample size were like below 30, would it be left skewed then? Or
Yeah,
would it still be normal?
it would be left skewed.
Okay. Okay. Yeah, that makes sense.
What is the mean of the distribution of the sample means for all possible samples of size 81 that can be drawn from the parent population? What? What is the mean of sample means
Don't mind.
for samples of size?
I think it's just testing your knowledge of, I forget which law it is, but the one that says like the mean of the overall distribution is the same as the sample distribution. So you just find whatever the mean is overall, and that's your answer.
So it would just be the, how do we find?
It's just in the
Oh, so it's 3.5?
Yeah, exactly. Does that make sense why though?
No, but
It's like one of the laws. I don't remember which law it is, but it just says there's a what do you call it? A blatant statement that just says that the mean overall is the same as the sample size mean.
oh, okay. Okay, that makes
So
sense.
the
I
answer is
remember reading that now.
3.5?
3.5, yeah.
Yep.
Okay, what is the standard deviation of the sampling distribution of the random variable x bar, the mean of 81 students who were selected? The standard deviation of sampling distribution. I have no clue. My brain's starting to fry. So.
No, I don't know.
So let's see. So it tells us the standard deviation of the overall population, correct?
Yes.
And so now we're just trying to find the standard deviation of the 81 students, so just the sample.
Uh-huh.
And so typically, the way that I figured it out was like the z-score formula, it tells you to divide by the standard deviation. But when you're doing a sample one, it tells you to divide by this the standard deviation divided by the square root of n. So if you think why you do that, it's really because the standard deviation of a sample is the population standard deviation divided by the square root of n. That's like the formula for it.
Okay, so we have to do that big long formula again?
You don't have to. You just have to do the denominator version. So like whatever's on the bottom, because that's what the standard deviation actually is for the sample. So it'd be the standard deviation. So tell me what number that is. 0.7? Yeah. So 0.7 divided by the square root of n is your answer.
Oh,
Does
okay.
that make sense? Why?
Okay, yeah, that makes sense.
I don't remember if it blatantly tells you that there's an equation for that in the reading, but I just kind of inferred that because the original formula was divided by the standard deviation, but when you did it for the sample, it was divided by the standard deviation divided by the square root of n. So you can assume that that means that's the standard deviation for a sample.
Okay, so the answer is 0.078?
Exactly.
Okay. That makes sense. It's
Sorry
nice
if
when
sorry if
someone talks it out, and then I can figure out the math. Okay, what is the... Yvonne, did you get that? Sorry.
Yeah, I got it.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So we have to find the z-score for 3.3, and then get the area for that, the left side area. I don't know if that's right.
I think that's right. That's what I
The mean. Wait, what's the probability? The mean GPA. So we have to do that big long problem again. So we have the, because it gives us 3.5, and then we have to do it by 3.3 instead. Is that correct to get the z-score?
So
you do 0.5 minus 3.3 over 0.07 divided by the square root of 81. Is that right?
yeah, like honestly, the numerator is interchangeable. Like you could put 3.3 minus 3.5 or 3.5 minus 3.3 because ultimately the z-score, whether it's positive or negative, you're just plugging it into the applet and it'll work out. So,
That's true.
but you're right. That's the formula.
7 square root of 81. Okay, now you have to put it into the calculator. Okay. So the z-score be 2.571.
it's
And then shade in left and then shade in right. So the area would be 0.0051.
Yeah, and then yeah, it's just 3 decimals, so just 0.005.
Okay. Oh, I'm getting it
Did
slowly.
you get it, Yvonne?
yeah,
Okay, awesome.
0.0051, correct?
But
Yeah.
don't put in the 1.
Exactly.
What is the probability that the mean GPA for 81 randomly selected BYO students will be greater than 3.3? Okay, so now we just have to do shade the right. But it would be the same thing.
No, because you need to shade in the middle, right? So it'd be 0.995.
Oh, that's right, because it all equals 1. That's right. 0.9949. Thank
Yep.
you. So it would be 0.995.
Yep. Does that make sense?
Yes, it does.
And just be careful. I actually missed that last one just because I put 2 decimal places. I don't know what I was thinking, but just make sure you don't like double up on decimal places or spaces throughout these fill in the blank or these writing questions.
Yeah. Okay, you good, Yvonne?
Yep, I got it.
Sweet. 100. Okay.
All right.
You guys get it?
Quizzes, and I'm really scared.
So whenever I end the call, is it gonna like save this broadcast somewhere?
Okay, so do you see a button that says stop broadcast?
At the bottom, yeah.
Okay, so you can do that first, and that'll stop recording.